Hey, welcome back to my YouTube channel. I'm Xavier Smith, and today I'm going to talk about the difference between observational studies and experiments. So let's just get into it. First of all, an observational study, as you can tell, you just observe people or observe data that's already been collected, or you're like, okay, we're going to see if caffeine causes you to have like more heart attacks, right? We're just going to look, oh, there's 1,000 people that we just say, like, do you drink caffeine? Yes or no? Did they have a heart attack like within this many years? Yes or no? You're not imposing a treatment. You're not saying, okay, this group of randomly selected people is going to have like caffeine, right, for the next 10 years. And the other group of people, randomly selected from like a big population, is not going to have any caffeine or very minimal caffeine for the next 10 years and then track their heart rate. Well, their amount of heart attacks. That second one, where you're imposing a treatment, you're imposing caffeine or no caffeine on them. Like there's a control group and then there's the one with caffeine. That's the experiment. You are imposing a treatment. So in an observational study, you are just observing people. You are not imposing a treatment on them. You're just saying, okay, what do they do? And then what happened to them, right? Like if they drink caffeine, how long do they live, right? You're just saying, okay, this person drank caffeine, they lived to 68. Other person didn't drink caffeine and they lived to 65, right? You're just looking at data. You're just looking at people, but you're not imposing a treatment or any control groups. And then from an observational study, if you're taking like, 1,000 caffeine drinkers, coffee drinkers, then you can only generalize it to those in the study. Like if you take a random like sample of the people, 1,000 people, and you take 50 of them and actually use their data, you can only generalize to the whole. And it's got to be random if you're going to generalize to the whole. If it's not random, you can only generalize it to the people that actually were in the study. Okay, and then this, like an observational study, you can say, well, I believe that caffeine causes like more heart attacks. Like it's statistically significant that they do from this study. But if it's if you just observe that happen, you didn't actually like impose a treatment, you can just say there's an association between like amount of caffeine and like number of heart attacks or like chance of a heart attack happening. You can say there's an association, but you can't say there's causation. So if it's like, did amount of caffeine cause these heart attacks? You can't say that because you didn't have like this group I'm giving caffeine, this group I'm not. There's too many variables here when you're just observing. You're just saying, okay, these people had caffeine, these people didn't. So when you're observing, you can't draw causation. You can't say caffeine caused heart attack, right? You can only say, well, from these people that I looked at, like the people that drank more caffeine had a higher percentage of heart attacks. So there's an association between amount of caffeine drunk and like percentage of getting a heart attack. So that's what you need from observational. You are not giving a treatment. You're generalizing to those in the study. And then it's association, not causation. So association is not causation. That's what you need to know. Association is not the same as causation. It means people in this study, yes, it looks like caffeine caused more heart attacks, but that doesn't mean the caffeine caused the heart attacks. Okay, in experiment, you're going to do the treatment imposed. You're going to impose a treatment on a group. So you're going to say, it's like 2 or more treatments. So you're going to say, okay, this group, I'm giving caffeine for the next 10 years. The other group, I'm giving caffeine for the next 10 years. Well, not giving caffeine for the next 10 years. And you want to have these randomly selected. If they're not randomly selected, you can't really generalize. You can only generalize to the people, like to those specific like 50 people or something. But if you just want random sample. So you're like, okay, we have these 1,000 people and we're going to put half of them into caffeine next 10 years, half of them into no caffeine next 10 years. And then you compare the amount of like heart attacks and the percentage of someone getting a heart attack. And then you'll say, well, since this group had caffeine and this group didn't, there is causation. And then you'll learn about something called like the alpha value, which is like 5%. And that's basically saying in like a normal study, if caffeine and no caffeine were like the same thing, we just look at how many heart attacks and then we like randomly pick samples, like 100 samples. And you're like, okay, does this like difference of the means happen more or less than 5% of the time? If it happens more than 5% of the time, you can't say causation. You're like, well, it's not statistically significant. It looks like there's an association in this study, but not significant. We'll definitely get into that on another video. And if it's less than, you're like, oh, statistically significant causation, yes. But right now, you just need to know experiment means causation if you give a treatment to them. And then you, of course, will generalize it to all the people in the study. Even if there's 1,000 people and you randomly select 100, still selecting 100, you're randomly distributing like confounding variables, which can change like the overall answer because people have different things that'll affect them. But you're randomly selecting them, so that'll like randomly distribute them and not affect the ending as much. Well, thanks for watching, and I hope this video was helpful.